In this video here, we will differentiate by first principles, which is essentially using this formula above here. We will also apply the limit where h is equal to 0. So, in order to apply first principles, we need a few ingredients. First of all, I will write out what we call the derivative of f of x, and this is equal to the limit where h approaches 0 for f of x plus h, that's our second coordinate, our second y value, minus our first y value over x2 minus x1, which simplifies down to a h. You can see here that we need f of x, and we already have f of x here, which is our x squared. Therefore, we need our f of x plus h. I will go ahead and find our f of x plus h here on the outside first. And to do this, we will substitute our x here for x plus h. So we can see we have the square on the outside, and then we have inside of the x, you're going to replace that with x plus h. Expand this where necessary. In this case here, we're using perfect squares. And so now we can find our f dash x. So we're going to limit where h approaches 0. Now f of x plus h is, I'm going to use a different color here. Is there. Now f of x is x squared, so we're going to subtract x squared, and we're going to divide by h. Since we haven't applied the limits yet, we still need to continue to write our limit function on the outside as we go to simplify our expression here. So the x's cancel out. We still need to divide by h. So what I'm going to do is split up the h's here. I'll bring this up. We still haven't applied the limit yet, which means that we need to simplify. Now we can take this limit, because there's nothing left to simplify inside here. We can take the limit and apply it and substitute h equals 0. So therefore that limit function on the outside will disappear. And so we are left with 2x. So the derivative of x squared is equal to 2x. You can see that there is some sort of pattern here that we might be able to work out if we're looking at this, but we will explore that a bit further later on. So in these next few examples, I'll work through them, but feel free to fast forward, rewind, where you see fit. I might rearrange a few things here. Like so with this one. So I'm going to find out what f of x plus h is. You can see we are substituting f of x plus h in all the spaces that we need. So when we go to find our derivative, which is deriving f of x, we've got all of our ingredients here. We need to minus our f of x. Now, if we can see here, there are two terms for our f of x. X squared plus 2x. Be very careful that that negative has to apply to both of the terms. This is a very common mistake that I see over the years, that students forget to apply that. But by doing this negative and making it clear, you can see that the x squared terms cancel each other out, and also the 2x here also cancels out with each other. Likewise, or furthermore, you can see this 2x, all of these terms have h's in them, and we need to divide by a h. So I'm going to start moving through this a bit more quickly by cancelling one h from each term in the numerator. Now that there is nothing left to cancel out, we can apply the limit and substitute this into the expression inside the bracket, showing that h eventually does become 0. Therefore, our derivative is 2x plus 2. So, x squared becomes 2x. X squared plus 2x becomes 2x plus 2. Hopefully now you are sensing some sort of pattern between the original f of x and our derivative of f dash of x. I'll continue with these examples here. If you feel like you've got the gist of it, please go ahead and don't wait. Here's our f of x plus h. We are subtracting 3 terms here. X squares cancel out. Minus 5x cancels out with minus 5x. Plus 4 cancels out with plus 4. We're going to divide each term by h as well, which cancels out with this denominator of h. We are going to apply the limit now. X squared minus 5x plus 4 becomes 2x minus 5. You can see we've gone from 3 terms down to 2 terms. What's happening to that 4 there? It seems to be disappearing. It might also seem that once you get used to the formula of finding the derivative, it becomes an exercise of being able to expand and simplify. Essentially, that's what this exercise is about. You are expanding and simplifying algebraic expressions. I'm skipping a step here. In my expansion, so see if you can make that mental leap. Three x squared becomes 6x. Oopsies. 2x. Negative 2x becomes negative 2. Positive 1 becomes 0 again. What is happening to these constant terms? This is something we will explore in our next video. But this is how you differentiate using first principles. So if you'd like, please pause the video, rewind, rewatch if you'd like to revise. Thanks for watching.